So back to open sets. Yeah? Fine. So if you have the points, so we'll now try to write more formally what we learned so far. Yeah? So there are 2 points, say x and y. One of the ways of conceptual, and suppose x belongs to R and y also belongs to R, right? X belongs to R and y and x, suppose y and x both belong to R. So they are what? They are real numbers. One way of considering the distance between x and y is to consider x minus y absolute value, right? That's the way we think of distance. And to say that this distance, so if you think of all the y's which are at a distance less than, say, some quantity delta greater than 0. Think of some quantity delta greater than 0. Right? Now if you want to describe the set of y's which are at a distance less than delta from x, think of the set of all points y which are at a distance less than delta from x. How would you describe that set? That set you would write is a set of all y's which satisfies the property So how do you read this? This is a set of all y's which are at a distance less than delta from x. Okay, that's how you write the set. Okay, now, is this clear? Okay. So let's now define a delta neighborhood. Is that is clear? Sure. If there's somebody who has not followed this, yeah. Good, thank you for telling me. So, think of 1. Okay, so think of let x be equal to 1. Think of the set of all points which are at a distance less than 2 units from 1. So what would these points be? Think of let x be equal to 1. Think of all the points which have a distance of less than 2 from 1. So what will those points be? What will those points be? All points between minus. So this is 0, this is 1, right? This is 2, this is 3. Yeah? This is minus 1. Minus 2, minus 1. So set of all points which have a distance less than 2 from 1 would be what points? So this way all points up to 3 but not including 3, and all points 1, 2 up to minus 1 but not including minus 1. These are all points which are at a distance of, less than 2 from 1. We want to describe the set of all such points. How do you describe the set of all such points? Set of all such points y such that the distance from x to y is less than delta. Sure? What would that set depend upon? It will depend on delta and what is x. Right? Okay, so we can describe this as, say, a delta neighborhood around x. Right? We can describe this as a delta neighborhood around x. So what would a delta neighborhood be around x? Can somebody quickly say what that would be? Yeah, you would, if you have to define a delta neighborhood around x. How would you do that? set of all points which are at a distance less than delta from x is called the delta neighborhood around x. Set of all points which are at a distance less than delta from x will be called the delta neighborhood of x. Yeah? Right? Okay? Delta would be any distance. Delta would be 2, 1, 3, minus, 0.01, 0.2. If you have to describe the set of all points which have the specific distance delta, you call it delta, right? Sure? Delta is just some symbol which stands for a certain distance. Delta is just some symbol which stands for a certain distance. Right? Everybody gets this? Okay. So now let's define this more rigorously. What do I mean by saying that A belong to R? Let A be a. But what do I mean when I say A belongs to R?
A is a point that belongs to one dimension.
A is a real number. A is just a real number. A belongs to R, right? Let delta be any quantity greater than 0. Any quantity. 1, 2, 3, minus, 0.01, 0.05, half, 1/3, whatever quantity you choose, as long as it's a non-negative, non-zero quantity. It's strictly positive. The same thing as so let's try to understand this definition. So A belongs to R, delta be greater than 0, give a delta neighborhood of A is the open interval A minus delta on this side, A plus delta on this side, without of course including, why it's an open interval? Because it does not include the boundaries. You see, right? For example, what would be the delta neighborhood, what would be the one neighborhood of 3? What would be the one neighborhood of 3? So it would be 2, 4. This will be the delta neighborhood of 3. Why is it an open interval? An open interval is nothing but an open set on the real number line. Why would this be an open set? Because it does not include boundaries, or because every point of this set is an interior point. Any point that you see, you can always find some delta neighborhood around that point which is contained entirely within the interval. Therefore you call it an open interval, right? So an open interval is nothing but an open set in R. Yeah? Right? What would be an open interval? What would be an open set in a two-dimensional space? Would it be an interval, or would it take some other shape? It would be a ball. You call it an open ball, right? And if you put a three-dimensional space, how would an open set look like? A sphere. An open set would look like a sphere, right? Okay? Sure? So sphere without the boundaries. Yeah? A sphere without any boundaries. Right? Which, yeah. Delta is 1. And x is 3. So x is 3, delta is 1. So one neighborhood around 3 is 2 and 4. All points between 2 and 4, not including 2 and 4. Therefore it's called the open interval. Right? What would be the, say, 0.5 interval of 7? What would be the 0.5 interval of 7? 6.5, 7.5, all points between 6.5 and 7.5 without including 6.5 and 7.5. Again, you see that every point of this set is a interior point. So it's an open set. Yeah? It's an open set, right? It's an open set. Sure? Okay. Now, so this is fine. Why is it called radius del? Because it's del distance on this side, del distance, delta distance on this side, delta distance on this side, right? If you think of two-dimensional space, you will get a ball of radius delta centered around it. Alternatively, you write n delta of A is a set of all points x which lie between A plus delta, A minus delta. Or alternatively, set of all points x such that the distance from x and A, distance between x and A is less than delta. Right? Distance between, these are all alternative ways of writing the same thing. All that I am doing writing this is because it really economizes on the writing. If you start writing all this, just this sentence. Or this is a little more compact way of writing this. Right? As economists, we have to learn about very compact ways of writing this. Sure? Yeah? Is this clear to everybody? Is there somebody who has not followed it? Everybody's followed this? Yeah, thankfully. Yes, you also.
So why x minus a is less than delta? Why it is not equal to delta?
Because we are looking at an open interval, a set of all points at a distance less than delta. That's an open neighborhood. You see, that's why we called it a delta neighborhood is the open interval. Yeah? Because we are interested in the open interval, that's why the delta neighborhood.
Interior will come, but not on the side.
Not on the boundary. Yeah.
So if x is the point from which you are calculating the delta, then what is
Delta is given to it.
Yeah, delta
So
is
set of all points, so suppose I give you some delta, say 3, and suppose x is 2. So we are looking at a set of all points which are at a distance less than 3 from 2.
a is what?
A is 2.
And the x
No,
was-
A is all the points. All the points which are lying between delta distance from 2. We'll call them A. Right? Sorry, no, I was right in the first place. A will be 2. And then I will describe the open interval set of all points x which are at the distance less than delta from A. So we have fixed A to start with.
So a is 2 and x is set of all
Set of all
that-
points which are at a distance less than 3 from 2. So set of all points between -1 and 5, or say minus so 2 minus 1 and 5, not including -1 and 5. Those would be x, and that would be the open interval, and that would be the neighborhood. So neighborhood is a collection of all these points. Collection of all these points.
So X is the collection of all the points between -1 and 5. And the A will be
A will be the value that you fix. So if A is 2, you fix A as 2, right? So A will be 2. Yeah, for example, set of all people which live in less than 2 kilometers distance from her house, if she is A, delta will be 2 and X will be all those people. If you are asking a question about this lady, then she will be A, and all the people who live in less than 2 kilometers, right, will be the neighborhood, right?
From one person's house 2 kilometers distance, so delta
Delta will be 2, because delta is the distance. No? A will be that person's house, the location of that person's house. So for any fixed A, if you think of a delta distance around that A, then the set of all points which are at a distance less than delta from that point A is called the delta neighborhood of A. It's a neighborhood of A, right? A is the point. A is the point.
so A itself would also be the neighborhood basically, because it's
A would also be in the neighborhood. A will also be in the neighborhood. Yeah?
So what is X then?
X is a set of all points which belong. X is not one number. Say X is just any point which satisfies that requirement.
So X is all points in the neighborhood.
X is all points. Say, for example, I can describe the following. Let this class be the set of all students X who are in SEM 1. Right? So anybody in SEM 1 satisfies this criteria, so you call it X, and the set of all those points. Right? Sure? Okay. So now, okay, now again redefining an open set formally. I am doing back and forth with open sets, but let me redefine an open set formally. Explain this to me. Don't write down, just understand. You have a continuous image of this there.
So A is a subset of real numbers. So A, all the elements in A are real numbers.
So A belongs to R.
A belongs to R. And A is a set. So every element in A is an open. A is an open set. If every element in A, if for every element in A, there is a distance around it, which is also a subset of A, set A. So that belongs to A.
So basically, A will be an open set if every point of A is an interior. This is just an alternative way of saying it. All that we will say is, think of A. We are currently thinking of A as a set of real numbers. So we are thinking of A as an open, at some interval on R. If A has the property that if you pick any element belonging to A, then there is at least one delta neighborhood around that element which is contained entirely within A, which is a proper subset of A. Not necessarily a proper subset, which could be the whole of A. Right? Okay? So in that case, we will call A an open set. Now, who can repeat this definition for me? Shall I tell you the best way of figuring out whether you have understood this, understood anything here? Okay, I found it very helpful to do it. Think of your grandmother, right? Close your eyes and say whether you can explain this idea to your grandmother in 2 sentences. If you can, then you have understood it well. So how many of you can do that? Yeah, so what will you tell your grandmother?
A is a set that belongs to real numbers. So A is a part of real numbers.
So A is an interval on R. Yeah.
A is an interval on R. Now, we call it as an open set, as A is a part of real numbers.
Not all intervals on the real number line or open set. We will say, we call A an open set if it has the following property. You find any point of A, if you can find at least one open neighborhood around A, some neighborhood around A in that point, which is contained entirely within A. So think of A, we will call A an open set if for every point belonging to that set, there exists at least one open neighborhood which is contained entirely within that set. Right? So come on now, tell me how you will talk to your grandmother. So that's a sure shot way of making sure that you understood something. You can actually logically convey something. Because most grandmothers are very logical people. They ask you questions. Yeah.
I have doubts.
Yeah, bolo.
How much should we call it?
Pardon?
How much am I actually call it?
Please.
No, I have doubts. I want you to clarify it
Sure,
for me.
go ahead.
So you said this is the number of the student. This is the number of the student.
This is not the number of students. What we have is, so basically we have the real number line R, yeah? Then you have a set A belonging to R. We will say that this set is an open set if you think of any element here, any point here, right? If you find any point that is belonging to this set, if you can find at least one neighborhood around this point which is contained entirely within that set.
So can we call this open set a middle number?
Huh?
A middle point.
No. An open set is not a middle point. A set is a set. Right? A set is not a point. A set is in this case, it's a collection of elements. A set here is some interval on the real number line.
It's like a combination of all the numbers.
Yeah. It is, for example, set of all points. Think of all. What do you have? Set of all points between 3 and 4.
Sir?
Set of all points between 3 and 4 will be what? Set of all points between 3 and 4, there are infinitely many points between 3 and 4, isn't it? Except 3 and 4. So, the set of all points between 3 and 4, if you take the number line, 1, 2, 3, 4, set of all these points except 3 and 4.
So the third point is the number that lies between the three.
Yeah. So what now Faulius got it right. So let A be any point lying between 3 and 4. You will call that set an open set if for any point in this set you can always find the neighborhood around that point which is contained entirely within the set. So for example, why would the set of points containing 3 and 4 not be an open set? So think of a point which contains 3 as well as 4. All points between 3 and 4 and 3 and 4. Why will that point not be an open set? Because at 3, which is the boundary, you have no neighborhood around 3 which is contained entirely within the set. Some points of that neighborhood are outside the set. Sure? Is this clear? Okay. Now suppose, can a set containing only one point be an open set? Can a singleton set be an open set? A singleton set cannot be an open set. Right? Is the whole real number line an open set? A real number line is the whole real number line is a open set. Right? So everybody gets the definition of an open set in R? Right? In general, see, why is R important? Because we have thought of certain ways of defining distances, which are absolute values, x minus y, etc. Think of a world where these definitions of distances don't apply. Right? Then of course we have to think of distances differently and the whole definitions will change. That is the general subject in mathematics called topology. We are going to think of certain applications of those ideas in the real numbers. Right?
Sir, in the second line over there, we have written there exists a where delta is more than 0.
Yeah.
So always it is more than 0. Why?
Because all distances have to be positive. There are points which are lying up at a distance delta from A. So all these distances have to be positive.
Yeah.